Hi children, how are you all? I hope all you fine. So children, see that up to now what we discussed in that quadratic equations, in that first we discussed that roots of the quadratic equation. So by using the roots, those two roots are satisfying the given quadratic equation or not. Okay, next concept 2, that is related to if the roots will be given, then how to find that quadratic equation, or if the quadratic equation is given, then how to find the roots. Okay, these all concepts we learnt in that previous two concepts. Am I right? So children, here see that concept 3 what they given. So children, we know that every quadratic equation is having the two roots. Okay, and here the condition is the roots are real roots, and in the same way those two roots are equal or not, and those two roots are real roots or not, and in the same way those two are imaginary or not, and those two roots are conjugate or not. Okay, so these all conditions are there. So what about this all, madam? Yes, I will tell you, see here. For example, here 5x square minus 6x plus 3 is equal to 0. Something, one of the equation is there. Okay, one of the quadratic equation is there. We know that this is a quadratic equation. This is having two roots. Okay, those two roots. For example, here I am not finding the roots. Just I am saying, for example, 2, 3 are the roots of the some given quadratic equation. For example, 2, 3 are the roots of that given quadratic equation. So here we can say that 2 and 3 are which type of numbers? Those two are real numbers. 2 and 3 are real numbers. So we can say that those two are real roots. So the given quadratic equation is having that real roots. Okay, so like that we can say that. So children, here see that. So directly one of the equation they given. Okay, directly they are asking the roots are real or not. So how we can say that? How many real roots are there? How we can say that? Okay, so for that purpose, here we are having that one concept that is related to nature of roots. So every time we will not get the numbers like that only, no, minus 3, minus 4, or in the fraction form like that. Every time we will not get like that. Sometimes we are getting that root 3 plus 4 by 2. Okay, like that roots also we will get, no. Already we have seen in that worksheet 2. Okay, so that type of numbers what we will call them. Okay, so see here. Here ax square plus bx plus c is equal to 0. If ax square plus bx plus c is equal to 0, a not equal to 0 is the quadratic equation with roots. So this is the given quadratic equation. So to this quadratic equation, what are the roots, ma? With the roots x is equal to, we know that quadratic formula. So what is that quadratic formula here? Minus b plus r minus square root of b square minus 4ac by 2a. b square minus 4ac by 2a. So here we are having two roots. By taking plus, we will get that one value. By taking minus, we will get that another value. Am I clear to you? So here we are having the two roots. Those two are the values of x. Understand? So the quadratic equation ax square plus bx plus c is equal to 0, a not equal to 0 is the quadratic equation with the roots x is equal to minus b plus r minus square root of b square minus 4ac by 2a. Okay, we know this already, right? So here what we have to take? So children, in this one here b square minus 4ac. Here we have to consider the part b square minus 4ac. Then b square minus 4ac is the discriminant. The discriminant of the quadratic equation ax square plus bx plus c is equal to 0, a not equal to 0. Understand? So this is the definition of that nature of roots. So once again say that here the quadratic equation is there, that is ax square plus bx plus c is equal to 0. So that is having that roots are x is equal to minus b plus r minus square root of b square minus 4ac by 2a. Okay, so from this formula here b square minus 4ac is there, no. So this part only b square minus 4ac is called that discriminant. Okay, so here by using b square minus 4ac, by using that value, we can say that the given roots are, to that given quadratic equation, the roots will be without finding the roots, we can say that those two roots are real or not. Okay, and those two roots are which type of roots? okay, by using that b square minus 4ac. That's why we will call that b square minus 4ac is the discriminant of the given quadratic equation a square plus bx plus c is equal to 0. Am I clear? And this discriminant is denoted by, and it is denoted by delta or d. Delta or d. So children, see here. So delta is equal to b square minus 4ac. So children, here say that delta is equal to b square minus 4ac. So if that quadratic equation is given, means if they will ask that the roots are given, roots are real or not, the roots of the given quadratic equation is real or not. So here what are the conditions and how can we say that, how can we decide that? Okay, so see here, the conditions are, if delta is greater than 0, if delta is greater than 0, then the roots are real roots and unequal roots. Real roots and unequal roots. If delta is equal to 0, then the roots are equal roots. Equal and real, or real and equal. Okay. If the delta value is less than 0, then the roots are imaginary. Then the roots are imaginary or conjugate. Then the roots are imaginary roots and conjugate roots. Okay. So here these are the conditions. So if delta is greater than 0, then the roots are real roots and in the same way unequal roots. If the delta value is equal to 0, then equal roots and here real roots. Next, delta less than 0. So imaginary and conjugate roots. Imaginary or conjugate roots. Am I clear to you? So I will tell you one of the examples here. See here, for example, x square minus 5x plus c, 5x plus 6 is equal to 0. Okay, so this is the given quadratic equation, x square minus 5x plus 6 is equal to 0. So here roots are. So here roots are. So how to say that roots are here? See, how we can say roots are real roots or imaginary roots? Here what we can say? Real, unequal, equal, imaginary. Okay, for example, like this some options there. Okay, so x square minus 5x plus 6 is equal to 0, then the roots are real, unequal, equal, imaginary. So how we can say that? See here. So here first we need to find the delta. So no need to find that here the roots of this quadratic equation. So to find that quadratic equation, we are having that factorization method, or by using the quadratic formula we can find that roots. But here without using those two, by using the delta, here we can say that the roots are which type of roots. So delta is equal to b square minus 4ac. So here b is equal to minus 5 whole square minus 4 into a is equal to 1 and c is equal to 6. So which is equal to minus 5 whole square, so that is 25 minus 6 fours 24. So which is equals to here 1. So that 1 is the value of delta. So 1 means that is greater than 0 or equal to 0 or less than 0. That is greater than 0. So here what we can say that delta is greater than 0. So if the delta is greater than 0, what we can consider it? We can say that if delta is greater than 0, then the roots are real and unequal. So these two options also correct. The roots are real and unequal. So let us check once here. The same example here I am taking. X square minus 5x plus 6 is equal to 0. So to this equation only, the roots are real and unequal, we got it. Yes or no? See here. X square minus 2x minus 3x plus 6 is equal to 0. Just splitting the middle term. So take that x as common. So the leftover x minus 2. Minus 3 as common. Here also x minus 2. So which is equal to 0. So x minus 3 into x minus 2 is equal to 0. Okay. So here for the product of two roots is equal to 0 means any one of the expression is equal to 0. So x minus 3 is equal to 0. X minus 2 is equal to 0. So from this one x is equal to 3, x is equal to 2. So children, just observe that here we got the roots are 2 and 3. So 2 and 3 are real numbers or not? Yes, 2 and 3 are real numbers. Okay, and in the same way 2 and 3 are equal roots or unequal roots? Unequal roots. Am I clear to you? So without simplifying this step, directly we can go for that delta is equal to b square minus 4ac. So here by using that nature of the roots, here directly we can say that the roots will be, which roots we will get? Those roots are imaginary roots or conjugate roots, or here real or equal or unequal. Directly we can say that. Okay. So here one more example we will say that. So children, another example say here. So here the roots are, here the question is the roots are, which type of roots we will get here? See, real roots, equal roots, imaginary, next one unequal. Okay, for example this is the question. So see here how we can say that again need to find out the roots. No need, directly go for the delta. So delta is equal to b square minus 4ac. So here which is equals to b minus 5 whole square minus 4 into a is equal to 2 and c is equal to 3. So 5 square is 25 minus 4 2 is 8. 8 3 is 24. So again we are getting here delta is equal to 1, which means here 1 is greater than 0. So greater than 0 means what we can say that here delta is greater than 0. Again the roots are real and unequal roots you will get. Understand, this is multi-type question. See here real and unequal, or the roots are real and equal, or the roots are imaginary or conjugate. Understand? So see here, without simplifying this, without getting that roots, here directly we are saying that the roots of the given quadratic equation, those two roots are real roots and unequal roots. Understand? So this is the third concept. So still we are having some other points. So those all points we will discuss in that next video. So up to now just you have to practice these all questions. Okay? Thank you all. So hi children. So in the previous video what we learnt ma? We learnt about that nature of the roots. Okay. So we learnt that if that a, b, c are real numbers, then what we can say about that roots we learnt in that previous video. Now in this video we are going to discuss about that. Here the quadratic equation is ax square plus bx plus c, and this is also related to nature of roots. And some other concepts there I said no. So here only some other points. Here bx plus c is equal to 0, a not equal to 0, and in the same way here a, b, c belongs to q. A, b, c belongs to q. Now what will happen in that roots? Okay, so this is our concept now. So here also some conditions are there. So what are the conditions? See that. Here the first condition is if delta is equal to 0. Okay, so previous we discussed about that if a, b, c belongs to R, belongs to real numbers, then here if delta is greater than 0, then the roots are real and not equal. Roots are real and not equal. And delta is less than 0, then the roots are imaginary and conjugate. And delta is equal to 0, then the roots are real and equal. Okay, these 3 points we discussed in that previous video, and that is related to A, B, C are real numbers. Now here A, B, C are rational numbers. Okay, then here some conditions are there, see. So if delta is equal to 0, if A, B, C are rational numbers, then delta is equal to 0, then the roots are rational and equal roots. Rational roots as well as those two roots are equal. Okay, just like this one only. Here real, that's why is equal to means here real and equal. So here A, B, C belongs to Q. So rational and equal. Okay, and in the same way, if delta is greater than 0. Delta is greater than 0. Again here two cases there. If delta is a perfect square. If delta is a perfect square, then what will happen? If delta is a perfect square, then the roots are rational and not equal. Okay ma? So here we discussed that only one point related to greater than 0. If A, B, C are real numbers, then delta is greater than 0, then the roots are real. Okay, greater than 0 means real and distant we discussed. So come to this one here, if delta is greater than 0, here two conditions will be existed. Okay. So what is that? The first condition is if the delta value, we are getting delta is equal to 1, right? Previous we simplified some problems in the before video. So there we got that delta is equal to 1. Okay, so delta is equal to 1 means 1 is a perfect square or not? Yes, 1 is a perfect square. So at that cases, the roots what will be happen? Here delta is equal to 1. So that is a perfect square. That is greater than 0. So greater than 0 means the condition is roots are rational. Okay. And here roots are not equal. Clear? Next, the second condition is if delta is not a perfect square. Delta is not a perfect square. Then the roots are irrational. Then the roots are irrational roots. Irrational and not equal roots. Understand? So this is the next condition. What is that? If delta is greater than 0 and greater than 0 means any positive value. So if the positive value is a perfect square, then the roots are rational and not equal roots. Okay. And come to the second condition here, if delta is greater than 0 and in the same way here, the number what we got at the place of discriminant value is there, no delta value. If the delta value is not a perfect square, okay, not a perfect square, then the roots what will be happen? Then the roots are irrational roots and different roots. Understand? So this is the second condition. Next come to the third one, if that delta is less than 0. So delta is less than 0, then what will happen? Then the roots are imaginary and conjugate. Then the roots are imaginary and conjugate. So, madam, here you are saying every time imaginary and conjugate roots. So, what about that imaginary roots and conjugate roots? And sometimes we are getting that complex roots also. Okay, so imaginary roots means what is that? The square root of a negative number. So sometimes we will get that the root values are the square root of negative numbers. So those numbers we will consider it as imaginary numbers. So those numbers we can write as I by using that I. 4i, 3i like that. Complex numbers means 4i plus something. So the combination of real numbers as well as here imaginary numbers, we will get it as a complex number. Okay, so see here, so this is this is complex number, only like this there means that is a imaginary number, that is an imaginary number. So what about that conjugate roots? So conjugate roots means here, for example, 3 plus root 5, 3 plus root 5 is one of the root of a given quadratic equation. So what is the another root of this quadratic equation? So how we can say that? They given that if 3 plus root 5 is one of the root of a given quadratic equation, then find that another root. If they will ask like that, means simply by saying this one easily we can write that its conjugate root. So here positive is there, its a conjugative root is 3 minus root 5. 3 minus root 5. Okay, and if the roots are in the form of 4i plus 3, for example, 4i plus 3. So this one we can write it as 3 plus 4i. 3 plus 4i also, no? So here what is the another root? For example, one of the root of a quadratic equation is 3 plus 4i. Okay, what is the another root of that quadratic equation? Okay, so that is nothing but 3 minus 4i. So here we can say that 3 plus 4i, 3 minus 4i are the conjugate roots of each other. Are conjugate to each other. And in the same way here also 3 plus root 5, 3 minus root 5 are the conjugate roots of each other. Understand? And one more thing, here we should not change the symbol of that real numbers. We should change the symbol in front of either that is imaginary number or in front of that irrational number. Understand? So here we should not write that. For example, like this they given root 5 plus 3. So what is the another root? Here we should not write that root 5 minus 3. This is wrong. Okay, why? Because that symbol we should change in front of that either irrational number or imaginary number. Okay, so those all are some other conditions, but here those are not required. Okay, that is related to another concept. So see here, just conjugate roots means what is that? I am saying here, see that. So 3 plus 4i, 3 minus 4i are the conjugate roots. So one root is sufficient. In that given question, if you observe that any one of the root from this type of roots, immediately you can write that another root. Okay, so by using remaining process is same to find that required equation. Am I clear to you? Yes. So children, see that if that A, B, C belongs to Q, then these conditions will be happen. So and in the same way, A, B, C belongs to Z. Z means integers. At that cases what will happen? And here same. See that. So if delta is equal to 0, then the roots are integers and equal roots. And delta is greater than 0, so the roots are integers and non-equal, which means distinct roots. And here less than 0, so then here the roots are complex numbers and conjugate numbers. Okay, conjugate roots. Am I clear to you? Yes. So here imaginary, if the roots, if A, B, C are integers, then we will get that complex numbers. Understand? So see here, so this is about that nature of roots, some other points. So here I will tell you one example. So in the previous video, I told you that one example, but that example related to 2 times also we got that delta is equal to 1, so which is greater than 0. So greater than 0 means always that is a real number, as well as that those two roots are unequal, we know that. Okay, now come to this one here. Here the example, x square plus x plus 1 is equal to 0 is a quadratic equation. 0 is a quadratic equation. Just comment on roots. Comment on roots. So comment on roots means here which type of roots we will get. So without simplification we will get that. So here by using discriminant I will tell you, as well as by using that simplification also I will show you that roots. Okay. So here see that. I will show you by using the discriminant. So discriminant is equal to b square minus 4ac. So b square means here x before nothing is there means that is 1. So 1 square minus 4 into a is equal to 1 and c is equal to 1. So which is equals to 1 minus 4 into 1 into 1. So 4. So minus 3. So what is the value of delta here? Delta is equal to minus 3. So that is greater than 0 or less than 0? Less than 0. Okay. So why? Because here minus 3 is there. No. So minus 3 is less than 0. So we know the condition. If delta discriminant is less than 0, then what will happen? Then the roots are, if delta is less than 0, then the roots are imaginary. Imaginary and conjugate. Imaginary and conjugate roots. So see here, by using that quadratic formula I will show you this one. See here. So x square plus x plus 1 is equal to 0. So x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay, so x is equal to minus b. So x before nothing is there, no, so that is minus 1 plus or minus square root of b square means 1 square minus 4 into a is equal to 1, c is equal to 1 whole by 2 into a is equal to 1. So which is equals to minus 1 plus or minus square root of 1 square is 1 minus 4 whole by 2, which is equals to minus 1 plus or minus square root of, here 1 minus 4 is minus 3 by 2. Okay children, so when you observe this one, here we got that at the place of discriminant minus 3 is there. So under the root minus 3 is there means that is the square root of a negative number. So imaginary numbers means what? Imaginary means the square root of a negative number is called an imaginary number. Okay, we know that, right? So here how to write this one, how to express this one? By using that I. So we know that I is equal to root of minus 1. This condition we know that. So that's why we can write this one as minus 1 plus or minus square root of 3 into square root of minus 1. Shall we write like that? Okay, square root of a into square root of b is equal to square root of ab. That is the property of irrational number. Okay, whole by 2, which is equals to minus 1 plus or minus here root 3 and here square root of 1 means I, that is the value, imaginary number. Okay, in that number system we discussed about this one, complex numbers, imaginary numbers. So at that places we discussed that the value of I also. So I is equal to square root of minus 1 is the value of I, and I square means minus 1. Okay, so see here whole by 2. Understand? So here we got that 2 roots. What are those 2 roots, ma? Minus 1 plus or minus square root of 3i by 2. Okay, so here x is equal to minus 1 plus root 3i by 2, and in the same way or another root is minus 1 minus root 3i by 2. Okay, so children, once observe that, madam, here delta is less than 0 means always you are saying that imaginary and conjugate. So conjugate means I explained you, right? So conjugate means root 3 plus 5 is there means just we have to change the sign. So 3 minus of root 3 we have to write. Okay, so here just observe that the values are here which roots we got, those 2 roots are which type of numbers? Imaginary numbers only, no? Why? Because here wherever we can see that I, that is those 2 are imaginary numbers, and here minus 1 is there means that is related to complex number. Okay, why? Because this is a combination of a real number and imaginary number. Okay, so that's why we will call this one as a complex number. Understand? And conjugate I am saying no. So these 2 are conjugate or not. Once observe that here root 3 before which symbol is there? Plus symbol is there. Here root 3i before which symbol is there? Minus symbol is there. Just observe, except the symbols, the leftover all the numbers are same. Yes or not? So here we can say that these 2 are conjugate numbers. Of course, obviously. So here the roots are delta is less than 0. Okay. So here I taken that x square plus x plus 1 is equal to 0. So here a is equal to 1, b is equal to 1, c is equal to 1. So we can consider that ABC are real numbers and ABC are integers or ABC are rational numbers. Okay. So here if you consider these 3 are ABC are integers, then here we got that complex numbers. Understand, ma? So here this is about that nature of roots. So all the natures we discussed, and in the same way we discussed some problems also. Okay, so without finding the roots, by using delta value, easily we can say that the roots of the given quadratic equation are which type of roots. Okay, so this is about that nature of roots. So in that next video we will discuss about that the number of problems which are related to nature of roots. Okay, thank you all.